Welcome back, students, to one more series of your Bahadur Chemistry Numericals. Right, so I've done a series of NCERT numericals. Let's see the Bahadur Chemistry so that your complete analysis will be over. So the reason for me doing the numericals immediately after the concept is you'll have an idea, okay, where to apply which formula. Right, let's read this question. So here, and the first question given is, during 200 joules work done on the system, 140 joules of heat is given out. Calculate the change in enthalpy. Simplest numerical, isn't it? Let's do. We'll go gradually one after the other, slowly, but we'll cover everything. Right. What data is given? W is given to us. That is nothing but 200 joules. This is work done on the system. Whenever work is done on the system, remember, if the system does work, that is when the work is done. Now this is your system. Now work is done on the system. Then always the work will be negative work, remember, on the system. If you remember this concept, it is easy for me to write. Next, what is that? They have given me Q value, it is equal to 140 joules of is given out. Given out means it's nothing but minus. Now, what is according to the formula, what do we know? Q is equal to delta E plus of minus W. So work is done on the system. Work is, what did they say? Work done on the system, he said. Now, W work is, no, 1 minute. They said during 200 joules work done on the system, 140 joules of heat is given out. Right. So, minus W work is right. Okay, we've done right. So, now work, let us write, take out this delta E this side. Delta E is equal to Q plus W. So, delta is how much? Q is how much? 140 minus 140 plus 200 is equal to plus 60 joules. Okay, fine. So here minus W work is work done by the system, isn't it? Yes. Okay, this is the concept. Remember this. So this is simplest numerical which we have done. Let's see the next question. What do you give me? A system does 40 joules work on surroundings, as well as gives out 20 joules energy. Calculate its internal energy. Again, a simplest numerical. Let's read. What did they say? They said W is minus 40 joules. How much is Q value? This is minus energy is given out. This is surroundings as well as 20 joules of energy. So it is minus 20 joules. So very well known delta E, according to the first law, delta E is equal to Q plus W. So change in internal energy, how much is Q value? It is minus 20 plus of minus 40. How much do I get? Delta E is nothing but minus 60 joules. Very easy, isn't it? Right. Let's do the next numerical. They said a system does 100 joules work on surroundings, and by absorbing 150 joules of heat, calculate the change in internal energy. Again, they are asking us to find the change in internal energy. Let us note. So, W is equal to minus 100 joules. Work on surroundings, because when the system does work, always it is negative. Right? So, W is minus 100. How much is Q? It is nothing but 150 joules. Change in internal energy formula, delta E is equal to Q plus W. So, delta E is nothing but 150 minus 100. Delta is equal to 50 joules. That's it. Let's do the fourth numerical, simplest numerical. Right. What do they give me? A gas absorbs 200 joules of heat and expands against the external pressure. Means there is an external pressure of 1.5. The gas is expanding itself. 1.5 atmospheres from a volume of, how much is the expansion? 0.5 liter to 1 liter. Calculate the change in internal energy. Right. So here, what do they say? There is change in volume. What formula will we apply? We'll apply W is equal to P minus P delta V. P value is how much? W is equal to pressure 1.5 minus 1.5 into, from what is delta V change? That is nothing but from 0.5 to, this is your V1, this is your V2. So it is from 1.7 to 0.5. How much do I get? I get minus 0.75. So what is the unit? This is ATM and this is liter. So this is liter atmosphere. Okay, done. To convert this into joule, what do? We multiply it with minus 0.75 into 101.3 joules. Then you get an answer of plus 124,025 joules. Right? So what do they ask me? Change in internal energy, delta E I need to find, because there was change in internal energy. Delta E is equal to, how much they say? Gas absorbs 200 joules of heat, and this is the amount. So we need to subtract both, isn't it? So when I 200, one second, what did they say? They said from it absorbs 200 joules of heat absorbs. Here, how much is this? This one, it is 75 liters of this one, isn't it? P delta A. Okay, what are we going to do? We're going to subtract 200 minus 75.975. This so much joules. Okay. Did I convert one? How much did I get? This is, I think I've written wrong. Okay, this is a mistake. That is why I got confused. This is the thing. I'm sorry. I worked out. 75 is this. Okay, now I'll come back. 200 joules of heat expands. So this again, this is the amount of how much expansion it is taken. So we have subtracted from that. Now we will get plus 124.025 joules. I'm sorry, students. Right. So this is your answer. Delta E. Let's see the fifth question. Calculate the work done during the process when 1 mole of gas is allowed to expand freely in vacuum. Simplest numerical. Vacuum, when they say, always remember, when gas expands in vacuum, whenever gas expands in vacuum, what you should remember? P external is 0. Right? So an irreversible process. So irreversible process, right? Remember. So therefore, what can I write? Formula W is equal to minus P external V2 minus V1. So when P external is 0, because it is expanding in vacuum, because vacuum you don't have any air pressure. That means when this becomes 0, this whole quantity W becomes 0. So what is the work done in when some gases are allowed to expand in vacuum? The work done is 0. Remember that. Right, let's come back and see the sixth question. Students, welcome back to one more set of your Bahadur chemistry numericals. Now I'll be doing your questions. That is the sixth question. Fine. So please watch the earlier video for this. Yes, let's read. 2 liters of nitrogen at 0 degrees centigrade and 5 atmosphere pressure are expanded isothermally, okay, at a constant pressure of 1 atmosphere under pressure until the pressure of the gas reaches 1 atmosphere. Assuming gas to be ideal, calculate the work of expansion. Right. So here, what did they ask me? They've asked me to calculate the work of expansion. So see, they said external pressure is greatly different from the pressure of N2. Correct? They said because they said constant external pressure. The external pressure is only 1 atmosphere which is acting. But the pressure of N2, whatever is there inside, right, that is different. Both are different. This is 1 atmosphere, this is 5 atmospheres. So this process is irreversible. Right? I hope you understood this. Once again, when the pressure applied from the top, that difference if you're finding, that means it is irreversible reaction. It is not going front and coming back. There is a lot of difference between this one and this one. So what is important here? The process is irreversible. So how I said there's difference in atmosphere, that difference in pressure. So when the process is irreversible, what is the formula? Work done is equal to minus P external V2 minus V1. I solved this already in the derivations. Irreversible isothermal, irreversible expansion of gases. Right. So here, what is W? What is P external? Minded with 1 atmosphere. 1 into V2 minus V1. Fine. Right. So what do they ask me? Assuming the gas to be ideal, calculate the work of expansion. Here they've given me to find the work of expansion. Let's start. Now here, if I have to take, what did they give me? Given value, how much is V1? It is 2 liters. Isn't it? How much? 5 atmospheres until the 2 liters of V1 is given. 2 liters is given. V2 I need to find. How much is P1 given to me? 5 atmospheres. P2 is how much? It is 1 atmosphere. How much is temperature? 273 Kelvin. So we very well know P1 V1 is equal to P2 V2. I need to find V2, get this V2 out. I get V2 is equal to here this whole thing comes down, it becomes 2 into 5 by 1 is equal to 10 liters. Right? Now, what should I find? I need to find still W. Now I've got to change, isn't it? W is equal to minus 1 into 10 minus 2 is equal to minus 8 liter atmosphere. Because see here, we have written the formula, isn't it? V2 minus V1. So V2 value I got 10 liters. V1 I already have 2 liters. So I've written V2 minus V1. Right? Minus 8 liter atmospheres. Now I can substitute in the earlier formula, which like this one to calculate means from liter atmosphere I can convert the same liter atmosphere into calories. I can convert it into joules. How to convert? If you want the answer in calories, what should you do? You need to take this and multiply with minus 8 into 1.987 divided by 0.0821 and you get it in calorie when you multiply. Suppose if you want the answer in joules, what should you do? Minus 8 into multiply with 1.987 into 4.184 divided by 0.0821. You will get the answer in joules. So how much is this? First solve, you get an answer of minus 1810.10 joules. This is your answer. Right. Let's come back and see the 7th numerical. What do they give me? The internal energy change in the conversion of 1 mole of calcite from calcium carbonate to aragonite form is plus 0.21 kilojoules. Calculate the enthalpy change when the pressure is 1 bar. Given that densities of solids are given, that is 2.71 gram per centimeter cube and 2.93 centimeter cube respectively. Right. What should I find? I need to calculate enthalpy change. Okay. When such thing is given, let me write delta H I need to find. So what is the formula which I know? Delta H is equal to delta E plus P delta V. This is what I know because I need to calculate delta H. What is delta E? How much did they give? They've given plus 0.21 kilojoules. Okay. So delta E value is plus 0.21 kilojoule per mole. To convert this into joule, which is equal to 0.21 into 10 raised to the power of 3 joule per mole. How much is the pressure which is given? I'm writing the data here. P is 1 bar. Convert this 1 into 10 raised to the power of 5 Pascal. So bar to Pascal I've converted. Yes. So this is over, isn't it? Now see, basically I'm gradually doing step by step, one after the other numerical, so that you know finally I come back to delta H. Fine. So delta V. It's nothing but this side internal energy change of this one. See here, the conversion of 1 mole of calcite form of CaCO3 to aragonite form. So delta V is aragonite form. This means calcite form to aragonite form. This means this is the final one. So volume of aragonite minus volume of calcite. So what is this? How can I find density is equal to mass by volume? Densities are given to me. So I can divide by 100 by 2.93. Why did I write 100? So density is equal to mass by volume. So volume is equal to mass by density. Mass of calcium carbonate is 100 grams minus 100 by 2.7. So when I take this and I solve, I get an answer of minus 2.77 centimeter cube. So now substitute in this formula delta H value. How much did I get delta E? That is 0.21 into 10 raised to the power of 3. minus your P value is given as 1 into 10 raised to 5 into, I can convert 2.77 into meter also. How? 2.77 into 10 raised to minus 6 meter. When I solve this, I get delta H value equal to 209.72 joule per mole. Further convert this into kilojoule per mole. Delta H is 0. You're going to shift 3 decimals, 1, 2, 3 to convert into kilojoule. 209. It is, I'm sorry. You're shifting this. This becomes 0.20972 kilojoule per mole. Because you're shifting 1, 2, 3 into 3. This is the answer. So if we done one unit, so this is how you're going to do. Let's do question number 8. Right. So here what they give me, they said in a fuel, a device, okay, fuel cell, you have studied fuel cell in electrochemistry also. They said a device for producing electricity directly from chemical reaction. Methanol is used as a fuel and oxygen gas is used as an oxidizer. So the reaction here, I think this one is not given. I'll write the reaction. So what is the reaction? It is nothing but methanol plus oxygen. It is 3/2 moles. Gives me carbon dioxide gas plus water. So when I balance, this is 2. Okay, this is the reaction. Calculate the standard Gibbs free energy change for the reaction that can be converted into electric work. I need to calculate delta G naught. If the standard enthalpy of combustion for methanol is given, and calculate the efficiency of the conversion of Gibbs free energy change into useful work, and conversion of Gibbs free into useful work. Right. So first of all, let's see. First, copy the reaction. CH3OH plus 3/2 O2 gives me carbon dioxide plus water. So what should I find out? I need to find delta G naught R. What is this equal to? Delta F G naught carbon dioxide plus 2 into delta G naught by 2 moles, 2 moles. 2 moles of delta G naught H2O minus of G naught CH3OH minus of 3/2 delta G naught oxygen. This is the first of all standard delta G naught reaction. Standard Gibbs free means the energy change, the standard Gibbs free energy change for this particular reaction. Right. So using this, now I'll apply the values in this. How much is this one delta G naught? It's running by minus 394.36. And next value is how much? It is nothing but for carbon dioxide, this value. Next value is this. Next value is this one. Next value is this. Okay, 0. Let's write. So 394.36 plus 2 into minus 237.13 minus of minus 166.27 minus of this at 0 for oxygen, 3/2 into 0. I get, when I solve this, delta G naught value equal to minus 702.35 kilojoules per mole. This is the value, right? So they've asked me efficiency also. So what is the efficiency of conversion of Gibbs free energy to useful work? What is the formula? So for finding or for calculating the efficiency of conversion of Gibbs free energy change into useful work, what is the formula? Is equal to delta H naught, the standard Gibbs free energy change, by delta G naught, this one by delta H naught into 100. If I divide this, I get the useful work. Or efficiency also I can say. Efficiency, how much is efficiency? If I see, is equal to minus, I got delta G naught how much? Minus 702.35 divided by delta H naught, how much did I get? They've given us standard free minus 726. This is what standard enthalpy. They've given me minus 726 into 100. When I solve this, I get an answer of 96.7%. That means, what is the conclusion? 96.7% of Gibbs free energy can be converted into useful work. So you should write, therefore 96.7% of Gibbs free energy can be converted into useful work. That's it. Let's read the 9th question. What do they give me? For a water gas reaction, the standard Gibbs free reaction at 1000 Kelvin is minus 8.1 kilojoules per mole. Okay, right? Calculate its equilibrium constant. Whenever they give you equilibrium constant, simple, write the formula directly. It is minus delta G naught is equal to 2.303 RT log Kc, because that is equilibrium constant formula. Right. Here, what do they give me? They've given me minus 8.1. So minus in that minus becomes plus 8.1 into 10 raised to 3 into 2.303 into how much is R value? It is nothing but 8.314. Okay, log Kc, right? I can write it as this one, isn't it? So how much did they give me? They said Gibbs free energy at 1000 Kelvin. It is nothing but 1000 log Kc. So I take out Kc outside, I solve, I get an answer of 2.648 mole per liter. That is the thing. Right. Let's see. Next one is 10th question. Let's read it. So here they've given below. Okay, reaction is incomplete. I have the reaction. I'll write the reaction. They said the standard Gibbs free reactions, or the standard Gibbs energies of the reactions at 177 Kelvin. Okay, they've given a list of reactions which I'll be writing first, because when I typing this I could not write that. I'll write the reaction. What are the reactions? The reactions given to me is aluminium plus oxygen giving me Al2O3. Delta G naught for this is minus 2 to 500 kilojoules per mole. Let us balance. Aluminium is 2, so this is 2. Oxygen is 3, so 3. Next reaction which they gave is carbon plus oxygen giving me carbon dioxide. For this delta G naught value is minus 380 into 3, because it is, okay, let us first balance this. How much is this? Carbon dioxide, so oxygen is 2, so 3 carbons, this is 3, so multiply with 3, it is kilojoules per mole. These are the reactions. I need to discuss the possibility of reducing Al2O3 and PbO with carbon at this temperature. Is there a possibility? Now by equation, now what do we do? Let us subtract equation 2 minus 1. This is equation 2 and this is 1. Let us subtract. What do I get? 3 carbons plus 2 Al, the way 2 Al2O3 gives me 3 carbon dioxides plus 4 aluminium. Delta G naught values also you need to do. Do I get minus 1140 minus of 2 to 500. When I solve this, H naught value I get equal to plus 21360 kilojoules per mole. Now I've got delta G value positive. Now since the delta G naught value is positive, the reaction will not take place. That means Al2O3 will not be reduced by carbon. We very well know, unless the reaction is negative, it will be spontaneous, it will happen. But since the reaction is positive, Al2O3 will not be reduced by carbon, because this is a reducing agent. It will not be reduced by carbon. Right? Now, that is what they've asked you, isn't it? So, one more thing. They've given me PbO reactions. So I'll write the reactions also. Let's see. For the second set, PbO, what are the reactions? It is Pb plus oxygen giving me 2 PbO. Okay, 2 to 12, right? Delta naught G naught for this is minus 120 kilojoules per mole. Again one more reaction, carbon plus oxygen giving me carbon dioxide. Delta G naught value for this is minus 380 kilojoules per mole. Now what am I going to do? Subtract equation 4 by 4 minus 3. What do I get? Carbon plus 2 PbO. I'm subtracting this with this. Give me carbon dioxide plus 2 Pb. So delta G naught value also the same thing. Minus 380. I'm subtracting this with this. Minus 380 minus of minus 120. What do I get? I get an answer of minus 260 kilojoules. Now the reaction is negative. Delta G Gibbs free energy is negative. That means the reaction will be spontaneous. So reaction will be spontaneous. And what should I say? I should say PbO will be reduced by carbon. Will be reduced by carbon. That is what this is how you should do. So let's come back and meet with the 11th question. Yes, students, in the next video.